So, last but not least, we have Mr. Athanasios Andreou from Eurecom Institute in South France to talk about TranspAd.
Okay, this is working. Everyone can hear me, all right? I suppose, yeah. Okay, could you put it in? Hello, everybody. My name is Athanasios Andreou. Today I represent my team, which consists also of Loiseau and Oana Goga, and I'm going to talk to you about our tool, TranspAd, which is a collaborative tool to bring transparency to targeted advertising. Now, as many of you might know, targeted advertising enables advertisers to show specific ads to specific users that might be actually interested in seeing these ads and eventually clicking on them. Lately, it has become very sophisticated. For example, here we can see some screenshots from the Twitter ad campaign manager. And as we can see, apart from conventional targeting based on gender or language, you can do much more elaborate stuff, like target based on followers, interests, or behaviors. The last part is what we call online behavioral advertising, and it consists of monitoring a user's online behavior in order to infer some attributes about him or her, and then target based on these attributes. In Twitter's case, you can see it can be very specific. You can target users that had their car insurance renewed in October, or have gotten a financial loan, are expecting a child, or are even suffering from an allergy. This granularity can be scary because it's ultra fine. What is even more scary for the users is that at best, they have very limited awareness on how the ad mechanism works. And they naturally come up with questions like, why am I being shown this ad? Or what do advertisers know about me in general? These are the questions that we try to address with our work. In the recent past, there have been some studies that try to address these questions or fairly similar ones. They all have something in common. If we look at the ad mechanism, let's say the ad engine as a black box that gets some inputs, like the user's online behavior, and produces some outputs, which are the targeted advertisements, all these approaches look at the inputs, look at the outputs, and then they make the right associations in order to infer what the ad engine knows about the users. However, looking at the inputs might be perceived as a privacy breach by many users. After all, if someone is skeptical when Google is gathering data about him or her, he might be twice as skeptical if he's instructed to install some kind of Chrome extension that does exactly the same thing. Also, inputs might come from too many sources. Some of them might be offline. For example, there might be some companies that maintain some client lists and they share the data of the clients to the ad engine. So it's impossible to track all the inputs. So what we're trying to do here is to forget about the inputs and focus only on the outputs. So find what the ad engine knows about the users just by looking at the ads they receive. How are we going to do this? First of all, we have, of course, to ask users to give us their ads. then we are going to infer group properties of users that have received the same ads. So we're going to do this in a collaborative manner. Thus, the name that we have given to this idea, which is collaborative transparency. And TranspAd is basically a Chrome extension that implements this idea. In order to do this, first, it needs to detect ads, then, of course, to collect data from them. It needs also to collect some demographics or interests about some users. We'll talk about this in detail later. And finally, it needs to come with an inference mechanism. Regarding the ad detection part, it has been done now. This is actually some screenshot from our application. We take the same approach that ad blockers take. So we maintain some lists with ad-associated URLs or URL patterns. And when the page loads, we try to locate these links inside the page. After we have detected the ads, we collect from them the landing page, the ad image or ad text or any media content that might be inside the ad, and when it's possible, the ad engine link. By ad engine link, I mean the link that invokes the ad. Basically, if you call this link, you see the ad. It's not always possible to extract this. In this part, there were two persistent challenges. First, how to get the landing page URL. Since the user is able to visit the landing page, the URL is somewhere in the page. However, it has become a little of a cat and mouse game in order to grab this URL. You come up with something, and then they come up with something new. That's also the problem. This part should always need to be maintained, because things will change in the future. For example, just some few days ago, I found a friend's website where what they were doing is that they were loading traditionally the ad through an iframe, but the landing page URL was nowhere to be found inside the ad, but it was somewhere else in the page. So in order to gather data for one ad, you had to look to two different places inside the page. Another challenge is how to get the landing page content. This is not as simple as clicking on the landing page URL and visiting the site, because these URLs have some redirections and they get also some arguments inside in order for the ad platforms to know which ad instance was clicked in order to access the landing page, because this is how they get paid after all. So if we just click on this URL, we might commit click fraud. Currently, we address this issue by a simple pattern matching. We try to find inside the landing page URL some other URL. However, when we will have more data, if this is not enough, we might need to come up with something more elaborate. Since we're doing some kind of inference, we need ground truth. To this end, we have created a questionnaire, which is an optional step for the users, but we want, especially in the beginning, to encourage them to fill it. It had basically any question that we could think of, like their income level, their employment status, their job sector, sexual orientation, everything that we could think that it would be useful. However, since this might be very time-consuming for the users, we plan in the future to get maybe this data through Facebook or ask the users for their Google Ads settings, because they can provide some useful insights. Of course, here, having data from too many different sources and having many things optional, so not all users fill everything, will have the cause that we'll have data with different granularity. So here it will be really interesting to investigate how these different granularities will affect our inference at the end. Finally, we need to have an inference mechanism. This is not yet done in our work. But the idea is, as I said before, to infer group properties of the users that have received the same ads. So for example, if we have some ad that was shown to 60 people, for 45 of them we know that they are doctors and that they are from Maryland, then we can maybe infer that this ad is targeting Johns Hopkins doctors. Another thing that is very important when you're working with group inference is how to calculate a confidence on your inference. From previous work that we have done in group inference, we know that confidence depends in these cases on the homogeneity of the group, the availability of the attributes inside the group, and the size, of course, of the user group. So we have to find a way to include these quantities in our computation for the confidence. Here we will also have the most interesting research questions. Like, for example, right now we don't even know yet how to strictly formulate our problem in these two questions that we're trying to answer. And also, what will the estimation look like? We will have some kind of histogram. We'll do some kind of, let's take the top 5 values. We'll have some kind of localized logistic regression. We have many ideas here that we could employ, and we'll see how well work. And actually, this is the most important part. Even now, we don't know if this collaborative transparency will yield satisfactory results. In the beginning, we didn't even know if we could group users together based on the ads they receive. However, we gained some intuition to this using some data from Floodwatch. From those of you who don't know, Floodwatch is a Chrome extension that collects the ads from the users and then performs some kind of visualizations on top of them. Like, for example, they saw a time-lapse with all the ads that the user has received. They were kind enough to provide us with some data spanning for 1.5 years. There were around 1,700 active users, which were online for around 3.5 hours per day. And Floodwatch was capturing around 36 ads per day per user. So there were enough data to answer to this question, how many ads are being seen by more than one users. Well, in this plot, you can see the time-lapse. In the x-axis is each day. With black font color is the number of active users each day. The red is the number of ads received. And the blue is the ratio of ads shown to more than one users this day. What we see here is if we have more than 200 active users per day, around 10% of the ads appear to more than one of them. So we can group at least some users. Also have in mind that this is a very, very conservative estimation since the granularity is per day, and we don't group ads that might be very similar and might yield similar group properties. Also, at the end, we'll need to validate our results. In the bibliography, there are some methodologies through some controlled experiments that we could employ, but we could also validate, at least in the scope of Facebook, our results, because Facebook has some functionality which is called why am I seeing this ad? So it can give us some ground truth and check if we can evaluate our methodology. Currently, our tool is ready to collect the ads. It's ready to collect demographics. We will have it probably next month. We will have it ready to ship it. And we will ship it also with some initial inference in order to motivate early adopters. This will probably be some kind of NLP process on the ad and just extracting some tags to inform the users what this ad is about. Some teaser of how the application will look like at the end. For example, here we will have an ad, and on top of the ad there will be a sentence informing the users of why they received this ad. And also it will have a global profile of the users about what do the advertisers know in general about him. If you have any suggestions, I would be really happy to hear them. Also, if you want to help, we have proposed 2 projects at the hackathon. One for collecting ads on Facebook and basically also collecting the why am I seeing this ad functionality in order to validate our methodologies. And also one to create a tool to collect ads on mobile phones. We will very soon, as I said before, have a first version. We would be very happy if you would install our tool and participate in this collaborative transparency effort. We will, through the DTL folks, we will inform you. I suppose early December we will have an alpha version of the tool for you. Thank you very much.
Questions? Yes, on the back.
You had mentioned iframes showing up somewhere else in the website besides where the ad is going to go. I know I've been sort of trying to pay attention to iframes. I think they're actually very deceptive in general. I'm wondering, is there some way to even consider that a deceptive practice as according to the FTC? In other words, if you have an iframe and you stick it somewhere else besides where the ad is going to go, how is that not trying to hide something?
Well, probably they're trying to hide something. The problem is that they do it, so we have to find some way to...
Well, if you can find that and report it to them,
yeah.
That would be a way for them to say, oh, we didn't really mean to do that. We're stuck.
Oh, well, sure, yes, but for the scope of our project, we just want to find it and inform the user, so we're not thinking in this scope. Yes?
Thanks. It's fascinating. It's about, it seems like a lot of work. You have to, it's very ambitious. So you want to do an inference based on people's information that is not causal, and we want to do that in real time to give it to the person in practice. So it's just strike me as an extremely challenging problem. I would probably aim at half of that in an entire NSF proposal. So I'm just wondering, what are your secret magic trick to do this?
Well, we don't have some kind of magic. We are also still thinking of how to tackle this problem. We're thinking, there are some kind of methodologies that exist, like active learning, that you can build on top of predictions. So this can become gradually and linearly and not having to do the inference all the time. So this, I suppose, might help. However, still, we need also to do most of these things in the server side. It's really difficult to do it on the front. It's impossible. So for sure, we'll have some performance issues that we will need to solve. Yeah.
Yes?
I have a question about the demographics that you are collecting, because it's about privacy and how can be transparent to the users, and then you collect demographics. Yeah. And I think you collect demographics in order to explain why this ad was shown to the user, right?
Yes, because when we group the users that have received the same ads together, we need for some of them at least to know something in order to infer for the rest of the group. That's the main idea. Of course, this might be a breach of privacy, but we have it completely optional to the users. So if someone doesn't wish to do this, he can still get some results. But the thing is that the more people put these results, the better.
Of course, yeah. But I was wondering if the users do not provide any direct demographics, whether you can use indirect inferred information. So again, learning from the users. For example,
we don't want to go to this direction. We don't want to trick the users into to infer some things about them through indirect ways. We want to be direct in this case because we think that it's fairer for the analysis. If not enough users will not give, we have also this plan of trying to do some semantic analysis on the advertisements and try to infer from this some properties of the users that might have received these ads.
Okay, thank you.
All right, thanks again. A warm applause for all the speakers, please. So.